Hi, this is Heather Craig, the Director of Test Prep for Success. And I have a student who asked me for a little extra help for trigonometry. She's never had a trigonometry class before, and she's worried about these questions on the test. And I'll let you know, you don't actually need to have a trigonometry class in order to do well on these questions. You really only need about like a 2-week unit, say at the end of your geometry class, to do questions like this. So don't worry about taking the SAT or ACT if you haven't had trigonometry. You do have to put a little bit of time into learning the beginning concepts from that, but you really don't have to have a whole year or even a half-year class for that. Anyway, for my students' request, I am going to go through these 5 questions. I have all of these questions posted as a PDF file on my website. Please take the time to print it out and try them first, and then come back to this video to see the explanations for the questions that you didn't quite understand. So here we go. The first one says, in triangle WVZ, WU equals UZ. Let's make sure that we mark that off. WU is right here, and UZ is right here. I like to use those little hash marks to show that we have equal lengths or congruent sides. And the question is, what is the length of WU? I'll put a question mark to show that I need that. So what I have is 10 inches, right? That's the one length I've been given. I have an angle of 60 and another angle of 30. Well, the first thing I can do is say for sure that this angle right here is 90 degrees. I know that's 90 degrees because 30 plus 60 is 90. The 3 angles of a triangle always have to add up to 180. So we definitely have a 90-degree angle here. And that's great news. If this is a 30, 60, 90 on the one side, we must have another 30, 60, 90 on the right side. And I think we can show that because if you really wanted to prove it, you would prove it using the hypotenuse leg theorem, or the 2 legs of this right triangle. So here we're going to have a 60, here we're going to have another 30. And what we can really see is that this is going to end up being the whole triangle, WVZ. If you were looking at this as one big triangle, it's going to be equilateral, because any triangle that has the 3 angles of 60, 60, 60 is always going to be equilateral. So if this side is 10, well then this side is 10, and then this side is 10. We're almost there with our final answer. The question mark is not for all the way from W to Z, it's just from W to U. That'll be exactly half of our 10. So our final answer is going to be A, or 5. Now this is a nice trigonometry question. You might not even think of it as trigonometry because we didn't have to do sine or cosine, but by definition, trigonometry is questions about the measurement of triangles. So this would be a nice introductory question about trig. Now we're going to get to some questions with sines and cosines. So in this case, we have triangle ABC with right angle B. I see that there's no figure given with this question, so I'm going to draw my own. It's a right triangle. It says that the right angle is B, so let me put the B over here. A and C, it doesn't matter which one is which. But once you decide where they go, you can't change it. Stick with that single drawing. All right, now it says AB equals 1. That would be here. BC equals 4/3. And the question is, what is the sine of C? Well, if we remember from SOHCAHTOA, this is the mnemonic that helps you remember the formulas for sine, cosine, and tangent. I'm interested in sine. Oh, and I put an A where I should have put an H. So let me make sure I fix that. Here we go. SOHCAHTOA. This reminds me that the sine equals the opposite over the hypotenuse. Here, if I want the sine of C, the side opposite C is going to be your 1. So we have our opposite here. And the side opposite the right angle will be the hypotenuse. It looks like I don't know what the hypotenuse is, and I need to figure that out in order to solve this problem. I can figure that out because we can use the Pythagorean theorem here. So my two legs are 1 4/3. My hypotenuse is my question mark. So let's start with a squared plus b squared equals c squared, and then we'll come back and get the sine after I have this part figured out. So that would be 1 squared plus 4/3 squared equals what I'm looking for, squared. 1 plus 16/9 equals c squared. Well, in order to solve this, let's change 1 into 9/9. Plus 16/9 equals c squared. So 9 plus 16 is 25/9 is c squared. Now we're going to take the square root of both sides. If this were an algebra question, I'd be putting a plus minus right here. But in geometry, we always work with positive numbers, so I can ignore it only because this is a geometry question. The square root of 25/9 is 5/3. So now I have a hypotenuse, that's 5/3. And I'm almost done with this question. So my next step is to go back to figure out the sine of c. It equals the opposite, which is 1, over the hypotenuse, which is 5/3. And I just have to simplify this complex fraction. Remember, when you divide by a fraction, that's the same as multiplied by the reciprocal. So think of this sine of c as 1 times 3/5. And that's just equal to 3/5. Here's my answer, A. All right, moving on to the next one. Now we have to work with radians. It does tell you in the SAT, in that reference information, that there are 360 degrees in a circle and 2 pi radians in a circle. I don't know if that's all that helpful, but what they're getting at is that 360 degrees is equal to 2 pi radians. You're going to use this. You're going to use this equation to build a conversion factor, but let's simplify this a little bit. We can divide both sides by 2 and get 180 degrees equals pi radians. We're going to this is going to be a little bit easier to work with because they're slightly smaller numbers. So what we're going to do is we're going to be starting with 540 degrees. We want to convert that to radians. So we're going to multiply it by a fraction. The units that we are wanting to get rid of, we want to get rid of degrees, that goes in the denominator. The units that we want to have in our answer, that'll go in the numerator. And then I want to make sure the numerator and denominator are equal to each other. So we just see here that 180 degrees is equal to pi radians. So I'm going to have to reduce this fraction. Let's see here, I'll cancel the zeros. That's a degree symbol, that's not a 0. It's a little better. I'll cancel the zeros. 54 goes into 18. Let's see, 18 goes into 54 3 times. So I'll cancel the 18 and turn my 54 into 3. And now I can see that I'm just going to multiply the 3 times pi. 3 times pi radians is the conversion. Okay, so let's read the question one more time to see what we're looking for our final answer. 540 degrees can be written as k pi radians, where k is a constant. Well, I found out that 540 degrees can be written as 3 pi radians. So the value of k must be this right there. The 3 and the k are the same thing. My answer is going to be 3. Effectively, all I did to answer this question was I took 540 and I divided it by 180. I spent a lot of time talking to you about why that was the case, but if you're practicing this question, you can go ahead and just do that division when you get it on the SAT. Here's question number 4. In the triangle shown below, there's a lot of data, so little by little, I'm going to take each piece of data and put it into the figure. So EH equals 24. HF equals 12. The cosine of E equals 12/13. So what I'm going to do is, first of all, remember that SOHCAHTOA again. CAH here reminds me that cosine equals adjacent over hypotenuse. So keeping that in mind, that the cosine is the adjacent over the hypotenuse, I'm going to use this information about cosine of E equals 12 over 13. Now, unfortunately, I know for E, the adjacent is right here, is the 24. And the hypotenuse is here. But I can't just take the 12 and put it as the adjacent number because I already know that the adjacent is 24. So what I'm realizing though is 24 is exactly twice as big as 12. So for the adjacent, instead of saying that it's equal to 12, I'm going to say it's equal to like 12x. So let me put a 12x here. And the hypotenuse then, I'm going to take this denominator because the 12 is associated with the adjacent and the 13 with the hypotenuse. So this hypotenuse is going to be like 13x. And then looking that 24 is 12x, I think you can solve that equation in your head and say, oh, x must be 2 because 12 times 2 is 24. So now that we know x is 2, we'll say 13 times 2 is 26. Oh, I know what the hypotenuse is. The hypotenuse is 26 here. Okay. What is the length of FG? I've got to get all the way here to the other end of the triangle. So one thing I'm noticing right away are those numbers 12 and 13. And then I have them in their doubled forms, 24 and 26. That should be, when you're working with the right triangle, those numbers should jump out at you as being two parts of a Pythagorean triple. Remember, a Pythagorean triple is 3 integers that can form a right circle. In other words, 3 integers that make the pattern a squared plus b squared equals c squared. And it's really, really helpful to memorize the 5, 12, 13 Pythagorean triple. That means if you have 2 of these 3 numbers, you can always just get the third number, not by doing the equation, but just by remembering it. So I'm seeing that already here. I'm seeing a multiple of 12 and a multiple of 13. So I know this last one is going to be a multiple of 5. That's going to be my 5x. And I already figured out that x over here is equal to 2. So hi is 10. I don't think that we needed to find hi for our final answer, but I think we might use that. Now I've got to get, right, FG. So let's look at this. From 24, so 24 is part of sort of like the tip of the iceberg here, just the top of the triangle. And the whole triangle, the whole iceberg, is going to be 24 plus 12, that's 36. In other words, it's 12 times 3. So if we're going to go from 12 times 2 to 12 times 3, I'm going to go on this other side. I'm going to base it here on the multiple, on the side that's a multiple of 5. So if this one is 5 times 2, over here I want 5 times 3, or I want 15. So what I just did was I used sort of the tip of the iceberg and the whole iceberg, looked at them as similar triangles, and I set up a proportion. This tip of the iceberg had a 24, and the whole iceberg had a 36. On the sides where I had my unknown, the tip of the iceberg had a 10, and the whole iceberg, well, that was my unknown. That was what I was looking for. You can solve that by cross multiplication. I actually found an easier way to do it in my head, but if you have a calculator, go ahead and cross multiply to solve for this variable. What I did was I reduced this fraction. 24 over 36, they're both divisible by 12. That's 2 over 3 equals 10 over what? Well, now we can say 10 times what is 2? 10 times 5 is 2. So what times 5 is going to give me, 2 times what is 10? 2 times 5 times 10. So 3 times 5 is going to give me 15. And that was another way to get to the 15 without actually having to use your calculator. All right, one more question to go. Here it is in the triangle below, angle BAC is right. I'm going to make sure I mark that. What is the value of sine of x minus cosine of y? I think one way to do this, the second best way, I'll show you the shortcut in a minute, but the second best way is just by number picking. When you're picking numbers for x and y, we just have to make sure that they add up to 90, because I can see from my figure here that x and y together make up a right angle. So let's pick that x equals 30 and y equals 60. Okay, so get out your calculator. Make sure that the mode is in degrees, and you can see here I do have my mode set to degrees, and then I'm just going to do the sine 30 minus the cosine 60, and you can see that my answer here is 0. So that's the answer to the question. I don't know, do you trust it? Do you think that was like a little magical? I mean, I just kind of picked 30 and 60 out of thin air. That's how number picking works. What if I had picked something different? So let's try it. Let's pick something different and make sure that we feel good about this answer. Let's pick like 50 and 40. Those are two other numbers that add up to 90. Sine 50 minus cosine 40. And if you're doing this along with me, go ahead and pick anything else. Pick like 1 and 89. That would also work. I'm putting in my 50 and 40. And you can see once again, I got 0, just like I did for 30 and 60. It works out no matter what numbers you pick. As long as you pick two numbers that add up to 90, you are going to get 0 here. Number picking has proved it for us. You can pick as many combinations as you want. You're going to get 0 every time. So 0 is the correct answer for number 5. Let me show you the shortcut, even though we already have it answered. There is a theorem in trigonometry that says this: the sine of an angle is equal to the cosine of its complement. What this means is if you have two angles that together add up to 190, add up to 90 degrees, and x and y do add up to 90 degrees, and we know that because of the statement here that we have a right angle, that the sine of x and the cosine of y will be equal to each other. And I can also see here, well, I'm subtracting them. So if I'm subtracting something, and then what I subtract from it is equal to the first thing, I'm always going to get 0 when I subtract two things that are equal. So you can see no matter what number x and y are, as long as they are complements, this theorem proves that the answer is going to be 0. If you happen to know this theorem, you didn't even have to pick numbers. You could jump directly to 0 for your answer, but picking numbers really was a great way to do it as well. I hope that helped, and I will try and make some more videos and post them soon.